Hello everyone, this video is about the terminologies and functions. For the number system, we have the complex numbers that can be divided into imaginary and real numbers. Real numbers can be divided into rational and irrational, and rational numbers can be divided into non-integers and integers. And we have some examples. In imaginary, we have I, which is the square root of -1. Irrational means with surds or transcendental or ln or logarithm. And non-integers means it can be fraction or decimals, and integers means whole numbers. We use the letter R, Q, and Z. Z minus means negative integers, Z positive integers. And mapping is the relationship or rule connecting inputs and outputs. For input or domain, we use the letter X. For outputs, we use the letter Y usually. For example, we have the domain and beds in the define, so the name of students, and the range is the list of universities. The rule is target university. For example, in maths, we have the domain 1, 2, 3, the rule y equals x plus 1, so 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. Domain and range, we use the letter x for domain, y for range, and we can just use a Cartesian coordinates. So we have 3 points in this example, and the domain, we can just list the domain, or we can use this notation between 1 and 3 x element integers, so only 1, 2, 3. We have only 3 possible numbers in the domain and 3 numbers in the range 2, 3, 4. We can also have a line segment, which means the domain is not only exactly 1 and exactly 2, but it can also be anything between 1 and 2, for example 1.5, and the range can be not only 2 and 3 but 2.5 or 2.6, or any possible number in between 1 and 2, any possible number between 2 and 3, including root 7 and 1 plus root 7. So for domain, we say it's between 1 and 3. We cannot list all the possible numbers, and we say x element real. This is the case where we have a line this time, not a line segment, so it continues forever in this direction, continues forever in this direction, and we just say x element real, y element real, because the domain or the x value can be any number in the world, positive, negative, up to negative, positive, infinity for the range as well. Types of mapping, we have 1, 1, 1, many, many, 1, many, many, and this type of mapping is when we, for example, this is the function y equals x, and here we have no repetitions in the x value and no repetitions in the y value. One many means one x value can be mapped to different or many y values. One mapped to -1, one mapped to +1. So we can have repetitions in the x value. Many 1, we have repetitions in the y values, and many repetitions in both x and y. A function is a special kind of mapping where each x value is mapped into only one y value. It can be many 1 or 1, 1 mapping. There can be no repetitions in x value, so no repetition in x, but the y can be repeated. And the test to make sure that your graph is a function or not, you can just draw like a vertical line, and if the vertical line passes once only or not more than once, then it's a function. So for example, here we have, just look at the x values 3, 4, 5, 6, no repetition, so yes, it is a function. 2, 3, 4, 5 also a function, -1, 0, 1, 2 also a function, 5, 5, you see we have repetitions in the x value, so this is not a function. If we draw a vertical line, wherever this vertical line is, you see we have only one point of intersection between the line and the testing green vertical line and the red straight line in the graph. So one intersection, not more than one intersection, means we have a function. So this is a function. This is not a function because if we draw the vertical line exactly here, we have exactly the same line, so they coincide, and we say we have infinite number of intersections. So this is not a function. And here, if we draw a vertical line, we have two intersections, so this is also not a function. If we draw a vertical line anywhere, we have only one intersection, so this is a function. If we draw a vertical line, we have two intersections, so this is not a function. And if we draw a vertical line here, we have only one intersection, so yes, this is a function. And one-one functions are special kind of functions where each y value is mapped from only one x value. It can only be one-one mapping. There can be no repetitions in the x and the y values, and it passes the horizontal line test, and it's invertible or the inverse exists. So for example, here this is 1 minus 1 2 minus 2, no repetition, so it's a function. And minus 1 1 minus 2 2, no repetition, so this is a 1 1 function, yes. And here we have 3 4 5 6, no repetitions, it's a function. 4 4, you see we have repetitions in the y value, so this is not a 1 1 function. Minus 1 0, you see we have two minus 1s here, so this is not a function. And if it's not a function, of course it's not a 1 1 function. Here we draw a horizontal line test. You see we have 4 intersections, so this is not a 1 1 function. Draw a vertical line anywhere, we cannot have more than one intersection, so yes, this is a 1 1 function. This, remember, is not even a function. If it's not even a function, of course it cannot be a 1 1 function. This is a function, and it is a 1 1. I mean, it's not a 1 1 because we have two intersections using the horizontal line test, so this is not a 1 1 function. And here this is a function, and it is a 1 1 function because it passes both vertical and horizontal line test. This is also a, I mean, yes, that's a 1 1 function. This is also a 1 1 function. So in conclusion, we have types of mapping, not functions. If it's a function, it passes the vertical line test, and if it's a 1 1 function, it passes the horizontal line test, and if it's a 1 1 function, the inverse exists. So we only care about the 1 1 and the functions. We don't really care about the rest. Right, that's it. I'll see you again next time.